You've seen tough bites out on the water, but what if the ocean changed the rules mid-cast? Today, scientists just logged a 10th anomaly in 3I/ATLAS, an interstellar object that keeps breaking comet playbooks. I'll show you why a brightness stretch at a 106-degree angle near the sun's direction and jets that vanish in an R-band filter have researchers saying the standard model won't hold stick with me to learn the checklist I use when nature stops behaving.
We've also been calling on NASA to release the image. The government is back open. No image. What do you make of this?
Well, thanks for having me. I was told by two sources that in fact NASA plans to release those images in a few days, in the middle of next week, that will give us much more information because 3I Atlas passed within 29 million kilometers from Mars when the images were taken back on October 2nd to 3rd. So let's just keep our fingers crossed because these should be the highest resolution images, and also they should be from the side of those outflows.
So you can spot rule-breaking signs on the sea and in the sky. Before we move on, I'd like to ask you a small favor. If you appreciate this content, please take a second to like this video and subscribe to the channel. Over 98% of you watch the videos without subscribing. It costs you nothing, but it makes a huge difference to us. So did you click the subscribe button? Great, thank you so much. Now back to the video. You set the hook and the line runs straight into the current. That's 3/ATLAS, pushing sunward, when every lesson says the tail should stream away. Let's dive in. The new Nordic optical telescope frame shows a stretched glow at about 106 degrees on the sky, while the sun lines up near 115 degrees.
I prefer to believe that storyline than any conspiracy theories at this time.
Okay, so the new images of 3I Atlas seem to show the tail is back. What is the significance? What do you make of this?
Unusual opportunity to get a high-resolution view of it. The case that was made is that they required some processing these images, and therefore they could not have been made public during the government shutdown. Well, actually, we don't just see a tail. In the latest images, we see of all the 7 jets coming from the surface of the central object, some of them towards the sun, some of them away from the sun.
The object sits about 1.43 astronomical units from the sun and 2.16 astronomical units from Earth. The crop spans roughly 500,000 kilometers across, like scanning a whole bay from a drone. You can see the light favored one side. It leans toward the sun, not away. Here's where it gets strange. Wide field shots caught long jets, but switch to the R-band filters that quiet most gas emission, and those long jets fade. It's like hearing a splash, but your sonar shows blank water. When gas lines get muted and the structure thins out, you're not reading classic gassy plumes, you're looking at dust or sunlight bouncing off grains. With a normal comet, dust trails downwind, the solar breeze pushes like a steady tide, and the dust tail runs leeward. Anti-tails show up when geometry stacks the deck along the orbit line, but this feature points sunward. That's a salmon sprinting upstream in dead still water. No tide to blame, no crosswind to hide behind, just the flow going the wrong way.
And the length of these jets is 1 million kilometers. You would expect that the material making up these jets had to go across that distance over a period of a month. What surprises me is that they are tightly collimated, and that is surprising because the object is rotating. The last time we checked, it has a rotation period of only 16 hours, given the typical speed of outflows from comets. And during a month, it would have been smeared by the rotation of the object. So then the question is, what is going on?
Now take the jet outflow read at this distance. The expected outflow lands near 0.4 of a kilometer per second, about the sound speed in that gas. Keep that pace moving for 1 to 3 months and carry the mass 1 million kilometers out, and you get a density count in the millions of protons per cubic centimeter out there. Multiply by the outflow speed and the flux turns huge, like a fire hose measured in billions of tons per month per million square kilometers. That's the claim on the table, and if you accept those numbers, the source has to feed a lot of mass for a long time. Translate that load to deck terms. To drive that outflow with sun power, you'd want a hot, broad hull, tens of kilometers across, But the body's size limit from Hubble sits around 5 to 6 kilometers. That's a skiff pulling a freighter's wake. If the wake is real and that big, the engine doesn't match the spray. Something in the math, the fuel, or the shape has to give. Go back to the R-band. Those filters cut out most of the usual gas lines. If the jets vanish under that filter, then the structure we're chasing is either dust heavy or reflectance built.
Another possibility is that perhaps the object broke up and what we see is the trail of material from the fragments flying out. But the problem is that we got the latest image and it looks like a single object in the middle. One possibility is that it's only the pockets of ice facing the sun that are getting warmed up, but we see jets going on the opposite direction, away from the sun. So we don't know what is going on. Of course, it's possible also that these are thrusters from a technological object that are used to maneuver or navigate. And obviously, in that case, they will maintain their orientation.
That means the brightness could come from sunlight bouncing off a grain flow, not from gas glowing on its own. It also means the simple gas drive model won't explain that sunward stretch on its own. You'd check grain sizes, charge effects, and how light pressure sorts fine dust. You'd also check for a thin forward scattering sheet. Dust can glow brighter when you look near the sun's line. Stack the earlier odd fronts quick. The path runs retrograde, yet hugs the ecliptic tight. A solar-directed jet showed up in late summer. Size and speed point in the wrong order. Composition hints lean metallic, not a dusty snowball. Water sits scarce. Polarization runs strongly negative. The approach line's near the old WOW signal direction. Near perihelion, the light surged blue. And now we see solar-directed behavior in this new frame. 9 fronts, 1 squall line. Each one by itself is a squall. Together, they look like a weather shift. So here's the payoff in this stretch. The 10th anomaly ties the set. Directional brightness points sunward, while the spectrum goes quiet in a band that hides gas. When tails run against the tide and your sonar goes silent, you stop treating it like a standard bite. The usual lure won't tell you what's going on. You need a new read, a new plan, and a slower hand on the reel. Next, I'll hand you a simple checklist: how to work unknown water, and how to read a sky oddity when the rules stop working. We'll break it down so you can test a claim, scan the field, and call a clean shot before you swing again. When the signal runs against the current and your tools go quiet, stop guessing and switch to a method. Observe cleanly, compare against known cases, stress test with simple checks, then decide on what holds up. Use that checklist on your next weird bite and on the next 3I/A TLAS update. Share your read in the comments and subscribe for more trips and tests. Watch how your calls get sharper when you work the steps. The ocean and the sky both reward patient skeptics. Watch for the rule break, then work the pattern. That's how you stay steady when the water pushes back and the gear stays silent.